Section 4-1 is congruent figures. So congruent figures have the same size and shape. So when two figures are congruent, you can slide, flip, or turn one of them so that it fits exactly on the other figure. So for example, this rectangle, I can slide this and it will fit exactly on top of the other one. Here's another example. I can take this triangle here at the bottom and I can turn it upside down and turn it over and it will fit exactly on. This is a flip. All I have to do is take this quadrilateral on the left and flip it upside down so that it lands on top of the one on the right. So congruent figures have the same size and shape, but they don't have to be in the same exact position. Now, this rectangle would not be congruent with this rectangle. It might be proportional, but it's not congruent. Their size is different. Okay? Congruent polygons. So, same idea, a little bit more definite, a little bit more precise definition. Polygons are congruent if they have the same congruent corresponding parts. In other words, they're matching angles and sides. So when you name a congruent polygon, you have to list the corresponding vertices in the same order. So here's a couple pictures of two congruent polygons. So I need to list that their sides are the same and their angles are the same. So the sides. AB is congruent with EF. You note that I did them in the same direction as the figure, from A to B and E to F. CD is congruent with GH. BC is congruent with FG, and DA is congruent with HE. What about the angles? Angle A is congruent with angle E. You notice this is a flip. I would have to flip this figure over to make them congruent. So when they're laying on top of each other, angle A is congruent with E. Angle C is congruent with G. Angle B is congruent to F. And angle H is congruent with D. So with that said, I can now say that the figure A, B, C, D is congruent, and watch the word direction you're going. If I started here and went this way, I've got to start here and go this way, is congruent with E, F, G, H. So make sure your congruency is going in the same direction. Okay, finding congruent triangles. So triangles are congruent, remember, when their corresponding sides and angles are all the same. So I'm going to look at this and I'm going to say, oops, let me back it up, sorry. So I'm going to start with the givens. BC, oh goodness. Okay, BC is congruent with CD. So BC is congruent with CD. The other, oh my goodness, let me try this again. Okay, the other things that are congruent by symbols, so that was the first one that was shown. I also have ED and AB that are shown as congruent. Yeah, AB and ED. AB and ED, and those are both given by the symbols on the figure. I also now can say that AC is congruent to CE, and my reason is that AC equals 6 and CE equals 6. So therefore, AC equals CE. The third thing I want to do is give my given angles. So I have a couple angles that are shown in the picture. I've got angle A is congruent to angle E. And I've got that angle B is congruent to angle D. And that's given by the diagram as well. So I need to also prove this inside angle. So I'm going to say that angle BCA is congruent to angle ECD. And I can't just call these angle C because there's more than one angle C in the diagram. The reason for that, can you tell what it might be? Vertical angles are congruent. So now I've shown that all of my sides are congruent. All of my angles are congruent, so I can now say that triangle BCA is congruent with triangle DCE. Notice the order I put those in, and the reason is definition of congruent polygons. Okay? A couple more things to look at. Theorem 4-1, the third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So in these pictures, okay, I can say if angle A is congruent to angle D, shown in the picture, and if angle B is congruent to E, then I can assume that the third angles are also congruent. So I can use that to prove triangles congruent. So here's a nice little picture. Whoops, that's an M up top. Sorry, got cut off. It's an M. So given from the diagram, LM is congruent to LO. MN is congruent to ON. So I've got two of my three sides congruent. And angle M is congruent to angle O. And MNL is congruent to NLO or OLN. Those are congruent. So that's all given. I want to prove that these two triangles are the same. So I'm almost there. I have two sides are congruent. I need the third side, which is the middle one, LN. And I have two angles congruent, and I need to prove these two are congruent as well. All right, so let's take a look. Number one, I'm going to do my givens for my lines. So I'm going to recopy this. LM is congruent to LO, and MN is congruent to ON, and that's given. My last one, LN is congruent to LN. That's a reflexive property of congruency. Remember, something is congruent to itself. Reflexive property of congruency. So that takes care of all three sides showing congruency. Angles, I have two given angles, so let's copy those. Angle of M is congruent to angle O, and angle MNL is congruent to angle OLN, and that's given. So now I have to show that angle, man, this pen is not working, angle number 4. Angle, let's see, MNL is congruent to angle LNO, and I can prove that by the third angles theorem. And then the last thing I have to say is that triangle LMN is congruent to triangle LON. And that's the definition of congruent triangles. Okay? And that's it. Be sure to bring questions with you to class, because we will talk about this before we continue our review for Chapter 3.